Hello everyone, we have Mr. Dorje Angchuk with us. He is an engineer at the Indian Astronomical Observatory at Hanle, Leh, and works at the Indian Institute of Astrophysics, Bangalore. He is among the key staff members involved in the commissioning and operation of the telescopes at the IAO. Apart from his professional contribution, he is an outstanding photographer, and his pictures have been featured in leading publications like the New York Magazine. So today he'll be talking about preserving the dark and starry skies, our natural heritage. So let's start.
Hi everybody. I hope I'm audible. Just to
Yes,
clarify, yeah, okay. I would like to thank IIT Mandi for actually inviting me to give this talk about our dark and starry skies. So, my name is Dorje Angchuk, and I am the engineer in charge at the Indian Astronomical Observatory, which is situated in Ladakh, UT, and this is on the China border. Just to give you a rough imagination where exactly this is. So, when was the last time you looked into the night sky? So, nowadays, with the flip of a switch, we can easily change day into night, night into day. We can change seasons, we can change actions, we can change state of minds. Light is everywhere, as you know, and it is used endlessly, and it is very much part of our modern lives. So, the thing is that how do we use it, and how is it changing our environment and our behaviors? A Starfield night once used to be an evening entertainment, but now it is Netflix, YouTube, Tata Sky, etc. So this is an image that I took 3 years back at Zanskar. It is called the Bhuktal Monastery. That is the remotest, as you can see, remotest part. It does not have any road. So why I'm showing this picture is that when I went trekking to it, it actually involved at that time to trek like 4 hours with all the cameras and equipment that I had. I reached there and suddenly it was cloudy, but then we slept over it, and then when we woke up at 1 o'clock, and the sky was totally clear, just like it is in the image. So when we came out, and then I was never expecting this at 1 o'clock in the middle of the night, the monastery itself to be so lighted up. So that was very actually, actually, what you can say. Actually, I was stunned by it. I never thought light pollution will be there. So basically, light pollution is everywhere, and we will have to think about it. Just a moment. Next slide. Hold on. Okay. Yeah, this is another image. I want to just give you a brief. This was taken this winter. Basically, this is a very interesting image where I was able to reproduce uh, basically the two aspect of the light pollution. Basically, on the left side, you can see the Leh city hugely polluted with light pollution on, as you can see behind the trees, whereas on the right side, just adjacent to it, you can see the starry skies. So my question was, which one would you like more? And as we go ahead, see, light pollution is there. So many people think that all light is good light, but and more light will be better. But light pollution is actually any light that is not needed and wasted going up in the sky, in the air. It is the light that is shining in your eyes and annoying you. So this is the image that I took, and I was very lucky just uh, to be able to showcase this image, because just after a minute the light went off at this monastery. This is called the Shemle Monastery. This is in the urban Leh area. So as you can see the difference in the next image, so definitely the light just went off, and it was very beautiful, and you can see the Ursa Major and the pole star on this end, and it was a very beautiful image. We can go these are all the green and the orange lights are the air glow that we can see here. Okay, so basically I'll be talking more about the light pollution effect on the night sky. Okay, so as we go ahead, so obviously the first and the foremost is the astronomy for which I'm representing. So it has got a very negative impact on the astronomy. As you can see, the light pollution in the there is this image that I've taken from the web about of Andromeda galaxy. On the left side, you can see it's from a polluted light polluted surroundings, and on the right side is from a dark sky. So, light pollution negatively affects one of our greatest natural laboratories, that is the night sky, because we have learned so many things from the night sky. So, basically, what do we get from astronomy? I can hear some disturbing noise. I hope I'm clear. My audio is clear.
Yes, sir. Your audio is
Janvi?
clear. We can hear
Okay.
you.
Yeah. Okay. So basically, what can we get from the night sky is that our ancestor used to study the stars, and even I remember my grandfather sometimes used to. We are still doing some farming. He used to tell us that, okay, oh, the bright star has come, so it's now that this early in the morning around 4 o'clock. He will say, okay, come, we have to go and harvest the field. So that was like astronomy is the oldest science. So we have learned many things from that, studying the astronomy, studying the stars. So this is image taken at Hanle, and basically we know a lot about the planetary motion. Here I've tried to simulate a small thing, planetary motion, with the help of a stellarium. I just try to make a movie out of it. So here, if it is visible to you, here we can see this is the planet Jupiter, and this is the Milky Way, and this is the dark horse nebula along with it. So here, our ancestors obviously used to look for it, look how the sky is changing. So what I can infer is that they would have studied something like that, and year by year, and they could have found that the Jupiter has 12 hours of orbital plane. So this is the image taken in simulated in 2007 on the 14th of May at 3 o'clock in the night. So as I made a movie out of it, so slowly the year, you can see the time and date, month won't change, only the year will be changing. So the Jupiter moved out of its way, but the Milky Way and all the stars, because they are stationary, they are at the same place. Obviously, moon will be changing, and Jupiter, as you can see, it's moving away, and suddenly it has disappeared from the sky at the same time. So we are in 2010, and but then it will be, it can be during daytime, Jupiter. So 2011, 2012. Jupiter is nowhere, and you can suddenly see Saturn coming. Now you can see Saturn jump is slower because it has got a bigger orbital plane. So you can see Saturn coming in. Saturn coming in. It made through 3 moves, and this is the Saturn, just for information. And then Saturn has reached here, so it is taking more time. Okay, Saturn has now reached near about in the same line of sight as the Milky Way. So in 2017 it was there, and now 2018 you can see Jupiter has again re-entered into our field of view, and this is the last one, 2019. So you can see Jupiter has again come back to the Milky Way position and near the dark horse nebula, as that has started in 2007. So this shows the planetary motions, and in fact, I was very lucky that one of my friend Ajit Talwar has taken a similar image from Hanle in 2007, and Jupiter around that time was near the Dark Horse Nebula. Okay, and similarly, last 2019, I took the picture, and it was very much near uh, Jupiter was. So this sort of confirms rough of the planetary movement, or that is the 12-year motion orbital plane of Jupiter. So the sky is our natural laboratory. So basically, 400 years back, when Galileo first he showed his he saw through the telescope towards Jupiter, he found moons of the Jupiter, and said that everything in the universe didn't encircle the Earth. So he also found that moons has got valleys, craters, and moon is not a completely spherical as people believe. So even India, it gave so much for astronomy. Like in 1868, French astronomer, he came to India for the solar eclipse, and during the solar eclipse, he found the spectral line that is at 587.49 nanometer in the spectrum of the sun, which was actually quite befalling because that it was helium, and it was not at that time it was not found in the Earth. So finally, later on, we got this helium also on Earth also. So this is the second most abundant, as you know, the gas or material. So and transit of Venus in 1700 was used to measure the distance of the sun from Earth, which is now called the one astronomical unit, that is around this much kilometer. And the transit of Venus in 2004, it was actually tested, and the dip in the intensity of the Venus across the sun was tested, and it was later used to find exoplanet in the Kepler missions. Kepler missions, actually, as you know, till date, more than 4,000 exoplanet has been discovered due to this dip in the intensity. So there are many people who actually they visit the observatory, and then they come to us, and then they will just ask, you are spending so much of money, so what do we actually get? What does the human actually benefit directly? So basically, our response is always like, see, these are fundamental science. We don't have any direct benefit to a layman while doing astronomy. But then astronomy had many spin-off, as you can see. So basically, the CCD, which is now in everybody's hand, the camera in the mobile. So that was actually first used for astronomy, and then in 2009, Boyle and Smith were awarded the Nobel Prize in Physics. The Kodak technical pan film originally was created by astronomers for studying the sun, is now used extensively in industrial photographers and artists. In 1977, John O'Sullivan developed a method to sharpen images from radio telescope, which is now implementing in uh, wireless networking. So nowadays, everybody knows about the X-ray luggage belts at the airport, and it was first used in astronomy, and now it is in the Chandra telescope as an X-ray observatory. And the aperture synthesis used in MRI and CT scans were first developed by radio astronomers. And GM used the astronomy programming language ideal to analyze data from car crashes. Fourth is used in FedEx track package, and it was first developed at the Kitt Peak Observatory for the astronomical studies. Now, and you know, GPS system, which is now very much everybody relies on the GPS satellites. So basically, GPS satellite also get all these positional information such from quasars and distant galaxy to know the accurate position. Okay. Hmm. Okay. So astronomy today is most of the astronomical observations, although are automated. So we also studies cosmic weather influence to satellites, whether the coronal mass ejection, it may affect our satellites or not. It's also critical to study the sun's influence on the Earth climate and how it will affect the weather, water levels, etc. Through astronomy, we also map the movement of all the objects in our solar systems, and it allows us to predict the potential threats to our planet from space. Such events could cause major changes in our world. Like you can see, this is a comparison of Comet 6P against the Los Angeles city. So this was so big, and we keep on looking into the sky to understand or predict any such happenings which can affect the Earth. And now, basically, yes, light pollution. So basically, light pollution. Now, I will come to the light pollution part. Light pollution is like mm, uh, many people talk about environmental pollutions, but they don't consider sky as the part of this as an environmental conservation or preservation. And all the conservation and preservation, the word or the term, this seems to stop at sunset, and they don't get carried to the evening, which I want to emphasize here. So this is my main objective, our own objective, that we would like to carry it on to the night and see a lot of dark sky parks, reserve sanctuaries across India, which can be called as parks after dark also. So the astronomers' ancestors use the celestial object as the same is a fundamental source of unlimited information. That is our greatest natural laboratory. Light pollution is also a major health issue. So light pollution also affects the wildlife. Light pollution is a huge waste of resources actually, and if used responsibly can be economical too. Our assumption that the more light means more safety is a contradiction, as it creates huge shadows which makes the hiding easily. I will come to each point one by one in the subsequent slides. So how does light pollution affect us? Basically, the light pollution is growing at the rate of 2% per year, which is more than the population growth, which is nowadays around 1.1%. And in fact, in developing countries like ours, it may be around 10% per year. Because there was no light previously. So this is the light pollution map of our Earth. As you can see, the darker signifies no light pollution, while as the color green, the red shows quite a lot burned out, and blue are light polluted skies. So here we can see more than half of our world lives in urban environments. So that means two-thirds of the world's population cannot see the Milky Way from where they live in. And there is this very interesting stories that happened in Los Angeles. In fact, in 1994, there was a major catastrophe. That is, there was a major earthquake, and suddenly in the middle of the night, there was a light outrage. So what happened? Everybody came running out. So this is, and then suddenly they saw a huge cloud of stars, and then it was they started calling the police that they see a big thing. Is it a UFO or something else? What exactly it is? There's a huge cloud. So that shows that people living in the urban environment are not aware of what exactly Milky Way is. So this is an I just got the image from this light pollution map.info. So this is an image that was taken in 2012. You can see the light pollution across our country, and then the subsequent image is last year's 2020. So you can see the changes in the light pollution level. So this is 2012, and next one you can see the light pollution has increased immensely all over India. So this is actually the light pollution map, and in our country, where more than 90% of the citizen cannot see the Milky Way. So this is where I think Mandi is around here. You can see my cursor, isn't it? And then Hanle is here. So definitely Hanle has got an advantage. So our main thing is that we want to see dark sky reserve parks everywhere in the country. But let us start with something from Hanle. So it will be like a torch bearer, or you can model sanctuary. So also this light emitting from the light polluted city like in US, like Las Vegas, can be seen from even 250, 300 kilometers away. So that is quite very, very polluting for people watching the night sky if they are inside the cities. So this much effect. So how do we quantify the light pollution? So the astronomers, or basically more like the amateurs astronomers, they use something called the Bottle scale, which actually quantifies data to achieve a figure which shows how bright or dark a certain area is. This scale operates from 1 to 9, and the 1 being the darkest sky you can possibly ever have a witness, and 9, where 9 would represent the city center. So this is how the amateur astronomers they quantify the skies around them. So this is like a light pollution 8-9 level in the middle of the city, in fact like Delhi, or you can say Mumbai, where you can see on the moon or the planets. And the other thing that you can see in the sky will be only aeroplanes passing over. So that is the only thing that you can ever see from a light pollution level 8. So next, as you can see more of the stars when you enter a light pollution level, this will be slightly smaller cities. You can see. So this is the light pollution level 6, and you can a little bit you can start seeing the Milky Way as it is emerging from here, and you can see more of the stars. This is the Sagittarius Scorpion constellation that is here now, which is more prominent. And this is a light pollution from a village. You be able to see, but on the outskirts of the village. And this is a light pollution level. If you go into the Himalayas, in Uttarakhand, etc., this you may be able to see it. Obviously, these are all taken from a similar image, similar exposure settings, and obviously our electronics cameras they have more sensitivity because they can we can be exposed it to more with more seconds or more time. So this is the pollution level 3, light pollution level 3. You can see some light pollutions occurring here. This is the light pollution from an pollution level 3, and you can see here this is the light pollution level 2. So you can see some lights. And this is actually, that's what I wanted to show you, that the light pollution level 1, this is taken at Hanle. This is a raw image and not processed. So this is what a camera sees. But then if you happen to visit Hanle, and it is like brilliant. Even I remember so many amateur astrophotographers from all over India, they came, and then they were like completely overwhelmed seeing the sky there. Actually, some of them told me that it brought tears to their eyes seeing so much stars. So definitely this is what we want to preserve. So we actually want to start with Hanle Dark Sky Sanctuary actually. So so this is the observatory. You can see the 2 meter. This is the 2 meter telescope. The dia of the primary mirror is 2 meter, and you can see some reflection of the stars inside. And this is the dome housing the telescope. Then it's more of a weather protection. The dome also independently follows the telescope wherever it is, and the slit is open towards wherever the objects are. So why Hanle? Why do we want to start with Hanle? So as you know, it's already established as a fantastic site for astronomy, which with scientific laboratories. We have got the Himalayan Chandra telescope, which I just show on, which is just on my back side and my virtual background. Then Hanle is also known for its wetland marshes, which is the home to lots of wildlife. And Hanle, we have got the astrotourism is a growing local industry because of its clarity, not only making money but also preserving nature too, and staying overnight, renting out spaces, and food industry, it benefits the locals at all, because we don't want to intrude or disturb the Hanle people. There's a village, cluster of village, so we don't want to disturb them by enforcing Hanle Dark Sky Sanctuary. And obviously everybody is getting benefited inside. And the other reason that Hanle is that Hanle is a very high altitude above sea level. So the Hanle is around 4,500 meters above sea level, and we have got more clearer sky at night because of the two factor that Hanle actually uh, it's placed such that that both our two major monsoon, that is the western disturbance, it does not reach Hanle, because all the snowfall that happens at Srinagar, Himachal Pradesh, and only the lighter cloud can pass and reach Hanle. So in the night it is mostly clear. And with regard to the southwest monsoon that will come in June. So all the precipitation that happens in the Uttarakhand, Himachal Pradesh, so only lighter clouds. Although we are now, because of the global warming, we are getting affected by the monsoon, but lesser than than the other parts of our motherland, that is India. So, and because of a higher altitude, we have got lower moisture in the atmosphere, and that the benefit of the lower moisture is that we can also see we have got a infrared sensor. As you know, the infrared rays coming from all the stars get absorbed in the atmosphere, in the moisture, basically. If it is not dry, if it's humid, that infrared light won't be able to reach us. So we can easily do infrared observation at Hanle, because it's dry and good transparency. This is a very good uh, point. A good transparency. Basically, I do photography, and what is the best thing about taking photographs in Hanle is that uh, basically your frames get filled, and it is so clear that everything looks very near, and uh, the whole frame is like enriching, and you can easily do photography. So that is one of the main reasons. So because of all the lights that's coming into the atmosphere, it does not get absorbed, and low light, low pollution, low aerosol, so you get very good transparency. The the story I would like to tell here, that when I actually joined the observatory, I told my neighborhood, that was 23 years back. I told my aunt in the neighborhood that I am going to Hanle. I just got a job there. She said, Hanle, oh, that's quite far away. And then inquiring more about it, she said that when we just started seeing the monastery from 25 kilometers, we never reached there, but the monastery looks very, very near about. So later on, I realized it was the transparency more, and everything looked very near. But when you start actually going towards it, then it is quite far. So that's because of the good transparency. And light is that. So basically, somebody has asked what we as a student can do to curb light pollution. So I'll explain in the later on slides. So this is another thing, that chart showing the number of visitors over Hanle. So it was growing very well, and exponentially going. So we want to make the locals also aware that they will get a huge benefit in terms of the wildlife. Basically, most of the people at Hanle are nomads. They have their own sheep, Pashmina sheep, goats, yaks, etc. And Hanle, as I told, Hanle has marshes, so there are a lot of wildlife, birds, etc. And just a moment ago, sometime back, just googled astrotourism in Ladakh, and that gave me a result of around like 3 lakhs result in like, well, in 1 second. So obviously astrotourism is growing, so that are also benefiting the locals. So why reserve a dark sky sanctuary? What is actually a dark sky sanctuary, or dark sky park, or dark sky reserve? So a dark sky sanctuary is a public or private land that has an exceptional or distinguished quality of starry nights and a nocturnal environment that is protected for its scientific, natural, or educational value, its cultural heritage, on or it's for public enjoyment. Anybody can visit it and appreciate the night sky. That's what our ancestors used to do. So, as a part of Hanle Dark Sky Sanctuary, we plan to cover a radius of around 40 kilometers. Right now, most of the dark sky sanctuaries are located around observatories. So, there are only around 12 dark sky sanctuaries all over the world. And once we have still not designated, but once designated, we will be the 13th one. While as there right now there are around 200 280 dark sky designated place all over, and mostly in US, Australia, where people have now got aware, and they have reserved this place for communities to view the starry skies, or to enjoy the starry skies. So the dark sky sanctuary must provide an exceptional dark sky resources, where the night sky brightness at the zenith is routinely equal to or darker than 21.5 magnitude per square second in the visual band. So this is actually taken from a sky quality measure, which actually shows that you can, if you have got very good eyesight, then you can see stars of magnitude around 20-21 magnitude, and basically as for the information that a brighter star have got less magnitude, like the Jupiter must be having around 2 magnitude, or the Sirius here must be around 3 to 4 or 2 magnitude stars. So mm, uh, we have got an additional advantage here, that the China has also established its first dark sky reserve in the astronomical for astronomical observation in the Tibetan prefecture of Ngari, which is also called Ali, which is just adjacent to Hanle. So together we can jointly impact for science how we can see the stars. So it will be good. What do we call coherent or existing beautifully in for the science, both our neighboring countries. So so Hanle Dark Sky Sanctuary will be India's first dark sky sanctuary, and it will attract many more tourists and astronomical institutions from India and abroad. So this is the image, and winter Milky Way image, and you can see this. This is the on the right side is the growth telescope. That is a robotic telescope. This is also we are operating in collaboration with IIT Mumbai, Professor Varun Balero. So this is a robotic, and it is used to observe transient phenomena like gravitational waves, etc., over the night. So how do we curb the light pollution? So in this a quality comprehensive light managing plan should be adopted. Like as you can see in the figure here, we should try to encourage fixtures which are actually like uh, directed towards the ground where is actually needed, and not directed to the sky where most of the light are actually they are wasted. So as you can see, this the one on the right most will be more efficient, and you don't need so much bright light. And we should encourage use of outdoors light only when necessary. And we should use curtains and windows so that light does not trespass our rooms and disturbs our neighbor. And vehicle moving at night should low beam light, because a glare can be very dangerous also, and it will be light polluting also. So, so this is a example of research light, which is done well and which is done badly. On the top, you can see this is light that is spreaded out, and it is just throwing away lights where it is not needed. So on the bottom, you can see a light where it's actually, and you can see the things or the place more clearly because of it when it is research light and done very properly. So if you want to get more information about all these things, I've got it from dark sky, idadarksky.org. You can find all the information about all this lighting management system, etc., and all of them. So this is another image of a conservation done well. So on the top, you can see a city which was like earlier light polluted, and then they did the research lighting later on. They are now even switching off all the street lights by 1 o'clock, 2 o'clock. So that's how people are getting aware. And then you can, if there are more light, there are more darkness. Obviously, because the shadows create, the light creates harsher shadows. So uh, more light does not mean that you are safe, or you can be safety. You can see more well. Okay, so the next thing is that many species, including humans, they need darkness to survive and thrive. And this is what the American Medical Association Council of Science and Public Health they found. I slowly come to it. So human also evolved to a rhythm of natural light, dark cycle of day and night. So these are the harmful effect. There is what the IDA people they have studied is that there are many wildlife like the birds, mammals, in fact, like turtles, which are actually they are getting affected because of the light pollutions. So the turtles are an iconic animals for studying the light pollution, because it has seen they have seen that the turtles uh, they start coming seeing the light pollution, they start coming towards the city. In fact, when they have to go towards the sea, when they see to see when the moonlight is there, uh, so that's what happens. Then when they come inside the city, they get either killed by on the road or etc., or they get killed by wild animals. And so this disrupts all migration, this increased predation, etc. So obviously there is a negative. You can see these are all this wildlife around Hanle. So Hanle is because it's not forest wetlands, so wildlife will definitely get affected if you don't. This can be true for any other places. So animals and plants live by rhythm based on the 24-hour cycle. Wildlife can become disoriented by too much artificial light at night, so which will interfere with that migration, mating, foraging for food, sleep. They won't get proper sleep, and then they will and then they won't be able to hunt well. It will disturb everybody. So similarly, what is the thing for our human? So light, you can see a street lamp here, actually, which is not properly done, and then it is trespassing into our house where we are sleeping, and also the direct glare you can see. So the glare in the eyes will be very blinding and can reduce our night visions. So there are a lot of research nowadays being done to discover the impact on our biological clock, and that is called the circadian rhythm. Basically, we have this artificial light at night. Actually, this disturb our night sleep night day-night cycle. So nighttime exposure to artificial water. So what exactly does it? Suppresses the melatonin production. So what does the melatonin product does that our bodies produce this hormone melatonin in response to the circadian rhythm, that's the day night cycle. So the melatonin keeps us healthy. It has got antioxidant properties, induces sleep, boosts the immune system, lower cholesterol, and helps the functioning of the thyroid, pancreas, ovaries, testes. So they are actually not directly, but then in fact it is found that the research have found that they have actually it's getting affected to everybody, and a lot of cancers are also because of the light pollution. This is especially true for the blue light, that is nowadays we are having the LEDs, so which are not very high wavelength. That's around, I will show the temperature range, and brighter does not mean safer. So you can see more light does not make us safer, rather it gives us a false sense of security. In fact, improper shielding can actually cause shadows, allowing perpetrators to take advantage of hiding spots which you cannot see. I'll show you an example. And in 2015 study published in the Journal of Epidemiology and Community Health found that the street lights, they actually don't prevent accidents or crime, but they do cost a lot of money for us. And so glare in the eyes due to bright headlights can be blinding and reduce our night vision. And obviously, they are cause of the major accident happening on the roadsides. So this is an example of non-shielded lights which are unsafe. You can see a student in the campus here. So the glaring lamp to the right of the path was installed to protect the students at night. But then in the next image, you can see the student is not there, but then he's in the image. So here we can see that improper lighting causes harsh shadow also. But the student is there, he's hiding under the lamppost, but you cannot see it. So he's hiding here. So too much glare, bright light is also cause glare. So that's also not good. So we mean to say that light should be properly done where it is actually needed, and not spread it all across. So and recessed light is very economical too. So recently in Tucson, Arizona, which is actually the hub of the astronomy, they retrofitted all the lights, and they brought the light pollution by 8%, and they could save $8.1 million in a year in energy costs. So light becomes cheap also, and there are many ways to use light responsibly by pointing it down. Use warmer color bulbs. So here you can see in this temperature chart. So whatever, basically, as a student or as a layman, we can always ask our vendors to give us light which are actually of lower wavelength, like less than 3000 warmer color, that's yellow. So these are actually, they have shown that they are not so much dangerous. But then the higher 8000 Kelvin, there's the white and blue LED, they are very harmful. Especially the blue ones are very harmful. And right now the white LED light, you can see they are also actually, it's coated. Basically LEDs are blue, so they are done some chemical processing, and then it actually the blue LED is seen as a white light. So we can have in fact, if we don't have too much light, then it becomes also easy for us to see clearly in the night, because otherwise there will be a huge contrast. So if you if I'm going out from a very well lighted room, and if you suddenly go out, then you won't be able to see, because your eyes takes time. And then uh, so if and the people will take some time to adjust to it. So if we don't have too much light, then it also becomes easy for us to safely walk outside, and we can have good walks also in the night and enjoy the night sky. So what do we have for the we can students, tourists, both astrotourism for wildlife can be more attracted with the help of this light, curbing the lights, and homestays resort, they can come up well. So all the Sanctuaries reserve will be a model program, and I'm sure all the other parts of the country will follow the same, thus helping us save our natural heritage, that is the dark night skies, and we can all enjoy and appreciate it. So what can we do is, so we can shield our lights. That's the, or if possible, we can use timer or motion sensor, so we can make it switch on whenever we are when needed, whenever we are passing through. So we can use lower wattage bulbs, save electricity, carbon or CO, and save CO2 emissions. Use warmer colored bulbs like yellow, amber instead of white, and develop local partnership, event lighting. I mean, we can ask the vendor to give us that type of warm colored bulbs, so that people can start and there will be more demand. Basically, what is business is what is, it's based on the demand. So if we have more demand of it, then it will become cheaper. So, and it will benefit us. And most importantly, we can appreciate and enjoy the night sky and teach and share with others. So this is just an image of this one. So the reference I've taken from all this is this light pollution map.info and www.darksky.org and podcast. So the summary is that we have to act before it is too late, conserve our natural heritage. Basically, light pollution is something that which we can preserve and conserve now, and we can do it by ourselves. So that is my main objective of this talk. And thank you. And the last, I will just show you a time lapse which I've taken last year in the pandemic. That is of the observatory. But then you can see lot of light is actually hampering the observatory, which are actually coming from very distant places. You can see a lot of lights also on the dome. So these are from headlights coming from nearly 7 to 8 kilometers far away. This is an all-night time lapse. Thank you. Am I there? Hello.
Yes, sir, you are audible. Thank you very much.
Yeah, thanks.
Sir, thanks a lot for the talk, first of all. And personally, I'm one of those who have suffered the most due to light pollution as I reside in Delhi. And while I was looking at the slides and the photos of the Hanle Dark Sky Sanctuary, I was like only just controlling my emotions and my longingness to just be there and enjoy the night sky. Anyways, participants, we are now open to any questions from your side.
Ayushman, there are already a few questions in the chat and in the Q&A.
Okay, sir. So we have a question from Aryansh. In the daytime, should we use excess light or would it be fine if we work in normal light?
I think best is if you have natural light. It's best to use the natural light because that is what from millions of years or what through the existence we always utilize that, and we are actually adapted to that type of light.
Okay, sir. And so another question is, what can we as students do to curb light pollution?
Yeah, basically, nice question. That's what my main intention is, that basically you are the upcoming generation, and in fact, if you are aware of the light pollution, whatever the hazards of light pollution, then obviously you can propagate it more and get it. We can influence our governments, local bodies, etc., to change the our fixtures and put proper shielded lights, and use. We can also ask them to, if it is not necessary, we can also always ask them to switch off the street lamps, outside lamps in the night, which is actually not required when there is nobody walking out, and we can easily enjoy the night sky also.
Thank you, sir. Sir, the next question is from Abhijit Manhas. Uh, are there any visiting student programs for BTech students in the Hanley Observatory for projects or internship, or just an education group trip?
Yeah, right. Basically, most of our educational programs or the recruitments that happens from II website, and then you can keep on looking at the II website whenever it comes. As such, Hanle being very far away, even from Leh, it is like 270 kilometers. So we don't have as such and continuous program going on. But in 2019, we have a summer astronomy school that happened here. That was the only first and the only one. Now, because of pandemic, we could not arrange more. But then definitely we will be having more of them. Please keep on looking at the IIP website, www.iip.res.in, and then you can find more about it. And yeah, regarding the also that is same for the PhD programs. But at Hanle, we are only engineers who are working for the development works, and most yeah, in fact, you can also find about such programs in the IA website.
Okay, sir. Thank you very much. So next we have a question from Divyansh. Why are we transitioning to white light from the yellow ones in cars?
Because of the low from studies, it has they found that the yellow light is less harmful, and with because of the longer wavelength, rather than the white light, which are having higher wavelength. And as you can see, example is that if you are actually this LED, this our laptop or mobile screen also LED. So if you are try to make a video in the night, so if you make a slow motion video, you can easily see there's the white LED light. They give lot of high frequency. They actually flicker a lot, which is also harmful other than the glare that they are doing.
Okay, sir. Thank you, sir. So next we have a question from Deep. Do greenhouse gases or any other forms of air pollutants play any role in trapping visible light and hence cause light pollution?
As of now, no, there is no confirmation. And but yeah, can you repeat that question? Sorry, I think I misinterpreted it.
Yes, sir.
Yeah.
So the question is, do greenhouse gases or any
Mhm.
other forms of air pollutants play any role in trapping visible light and hence cause light pollution?
Yeah. I think I don't know about the greenhouse gases, but then yes, light pollution, because when we see a lot of suspended uh, dust particles, etc., they because of the light pollution they glow. And you can this is what actually cause the city glow. Basically it's also caused because of all the dust particle aerosols that is actually suspended in the air, and it is giving a higher glow. So yes, it will affect definitely.
Okay, thank you, sir. So we have another question from Deep. That is, could there be an optimum wavelength of light which could be used for different devices such that they provide required visibility in the cornered region and then disperse over larger distances to scatter in non-visible wavelengths?
Can you repeat that, or can I see
Yeah,
the
sure, sir.
question somewhere? Yeah.
So the question is, could there be an
Mhm.
optimum wavelength of light which could be used for different devices such that they provide the required visibility in the concerned region and then disperse over larger distances to scatter in non-visible wavelengths?
Uh, I think I don't have the answer. I'm sorry about that, but definitely I can get back to him uh, from a better person.
Okay, sir, thank you. So next we have a question from Tushan Datta. Does light pollution play a major role in cancer, or is it just a minor part?
Yeah, basically, the study says that although it is actually creating problems, but then they have only indirectly shown that it is uh, causing it. But right now, there's no substantial direct. But it's like that. You cannot just pinpoint that it is happening directly because of that. But yes, because of all the melatonin, it is causing all the problem. That has been established.
Okay, sir. So then we have a question from Vivek Reddy Pininti. Does any telescope at Hanle has the facility to use laser guide star?
No, right now we don't have that facility. In fact, that is more used in adaptive optics also. Also, we don't have adaptive optics there, and that facility is not available at Hanle right now.
Okay, sir. Thank you. So another question is from Anmol. What new things are being planned for Hanle, if any?
Yeah, in fact, there are a lot of programs. Basically, I forgot to include that in the slide because I thought that will be out of topic. First of all, we have this 21-meter maze telescope that is being installed by Baba Atomic Research Center. Basically, it is a 21-meter large gamma ray telescope, which is just on the verge of getting seeing its first light. It is already installed. So that is one of the first thing that will be publicized because it is already undergoing many years. And then we have other projects with ISRO too. That is, ISRO is putting up a 1-meter class telescope to study the space satellites. That was supposed to come last year because of the pandemic last year, and this year it did not come. And then there is a major collaboration with ISRO and Raman Research Institute and Caltech. They intend to put uh, mm, uh, a 6-meter telescope that will be in radio. That will be a radio telescope to study, and subsequently the Caltech will also put another telescope that may not come in Hanle but somewhere in Ladakh in the western part. That basically that will be extension of the Event Horizon telescope. As you heard about the thing. So because most of the telescope for Event Horizon is actually they are in either US, Europe, Antarctica. So it's on that line, but we don't they don't have much another telescope in this part on the Asia this part Indian Ocean. So that whenever that telescope comes will be an extension for the Event Horizon telescope, and they're basically the base length will increase and they can have more clarity.
Okay, thank
And
you, sir.
okay, yeah, no,
Yeah.
sorry, I didn't finish because I just stopped at them. Another project that we have coming up is the National Large Solar Telescope. We just got the land for it. Maybe the funding will be released whenever the situation gets normal. Basically, this will happen at, if you have heard about Pangong Lake, that is the one of the highest lake in Ladakh, and it's a big one. It's just near China border. So we got the land. We did all the site survey, and this is we found that lake to be one of the best site for solar observation. So the telescope will be on the banks of the lake, where it will get laminar wind flow to get more better transparency during daytime of the sun observation. And then we have the our major aim is to have a big large telescope that is which is called the National Large Optical Telescope, which will be like 12 meters, 10 to 12 meters. And then we are doing all the site characterization for them for it. And then in subsequent, that is our future plan. So those are all the telescopes that will be coming at Hanle.
Okay, thank you, sir. The next one more question we have from Anmol. How can I, as an amateur astronomer, experience the telescopes at Hanley or just the environment in general?
Oh, Anmol, what you can do is basically it's such a fantastic place. You should actually uh, try to visit Hanle when it's a dark night and it's a clearer night. I can tell September to November are more clearer because of the sky conditions also. So you can try to visit even in the summer. You can try to visit on a dark night, not a moonless night, which I meant. So you can, and then the whole experience of seeing the star uh, from Hanle is unbelievable. Sometimes you can whatever the constellation, you will be confused which constellation is which way, by seeing so many stars.
Okay, sir. Well, sir, personally, I also had a question. Like, since I live in Delhi, so therefore there's a lot of light pollution here. So once I went on a school trip to Sariska, where there's low light pollution. So there, what I saw was that we used red tapings on torches instead of white light, so that we see red light, use red light. So is there any significance of that? And is there any
See,
relation to that?
if you remember that color diagram I showed, the red is actually the least harmful of that. So that is why people use it, but still, if possible, don't use that also. But red is supposed to be the least harmful of all of them.
Okay, sir.
Yeah. Okay, this one red is actually the least harmful of all the lights, and then it won't get you won't get disturbed.
Okay, sir.
Yeah.
Thank you, sir.
Thank you.
Currently, that's all we have in the chat box.
Yeah. Okay. Thank you very much for having me here again. It was nice experience for me also.
Yes, sir. We're also very grateful for having you here. Thanks a lot,
Yeah.
sir, for sparing time out of your very busy schedule, joining us from Leh, where you've just mentioned the connectivity
Yes.
isn't really that good.
Yes.
I, on behalf of AstraX, IIT Mandi, Stack, and all the participants, would like to thank you again. And all the pictures that you shared, those were very beautiful. All of us really wish that we could have been there when you were clicking them. Like, still almost like the Milky Way picture that you've been showing us like multiple
Yeah.
times. I can't even believe that so many stars can actually be seen without post editing on a picture. That's it, sir. Once again, thanks on behalf of Astrax, and here we'd like to end the keynote talk.
Okay. Thank you very much, Anmol, and everybody in the team. Thank you all. Thanks.
Thank you,
Thank you,
sir.
sir.
Thank you.